right, so today we're not going to introduce any new topics. We'll save that for Monday next week when we move on to arrays. Instead, we're just going to get some more practice by writing some more functions that use pointers, that do error handling, and ultimately we're also going to test those functions. I've got my book here, and we're just going to do as many exercises as we can. The first one that I want to do, though, is something that we've already done. What I want to do is I want to, now we're still in the financial utils here. This is not going to be financial anymore, so by all means I should put this into a separate file, but I'll just go ahead and keep going with this file. Generally what you do is you take and you collect all the functions that pertain to one thing and you put them into their own headers and source files so that you can keep things separately and organized. So that when you're only using this library over here, you only compile and bring in that library. The thing that we've already done before is to compute the roots of a quadratic equation. So do you remember how you do that? If you've got a quadratic equation, ax squared plus bx plus c, right? You need to find the roots of that. You use the quadratic formula. Negative b plus minus square root 4a, b squared minus 4ac all over 2a. Now when we did that before, we computed two roots, right? We had these two lines of code that did root 1 is equal to blah, 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 blah. Root 2 is equal to the other thing, right? But those are two results. We're not going to be able to return two results. If I did this without using pointers, what would I have to do? I would have to compute root A and then another function here called compute root B, right? I'd have to have two functions here. But because now I have pass by reference, what I can do is I can pass in two pass by reference variables, root 1 and root 2, and I can fill those buckets up with two values. Right? And I don't have to return two things. In fact, I'm not going to return a value at all. I'm going to return an error code. Right? So let's go ahead and think about what the inputs of this should be. So if you want to compute the quadratic formula, what do you need first? That's too big. What do you need to compute that formula? A, B, and C, right? Now, what should their types be? Are you always going to have integral values? No. In fact, most of the time you have floating point numbers, so double values. Double A, double B, and double C. Now, do I need to pass those by reference? Am I going to be making changes to them? No, I'm just going to be using them and putting them into a formula to compute the result of that formula, right? So I'm not going to pass those in by reference. I'm going to pass them in by values. That way, I'm not making any changes to A, B, or C. Right? Now, I will need to pass in double star root 1 and double star root 2. Those are my two pass by reference variables. That's where I'm going to put the results. You could call it result 1 and result 2, but what are they? They're roots. So root 1 and root 2. Now, what is my return type going to be here? That's going to be for any error codes. Now, in this week's lab and this week's hack, you did not do any error handling because that's next week. You'll be doing the same exercises basically, but you'll be identifying, passing stuff by reference and returning error codes instead. Okay, that is my signature. That's good enough. The first thing I want to do before I even get started is I want to make sure that I am writing this documentation. Right? The very act of writing documentation can help you figure out what you need to do in that function. What is the purpose of this function? What am I going to do here? Right? So computes the two roots associated with the quadratic polynomial. Say ax squared plus bx plus c equals 0. Right? We don't have to, we can go ahead and use this mathematical notation here because this is just comments, all right? In fact, if you want to do fancy comments, you might even put this into LaTeX, right? And now it would render or something like that. But I'm not going to go that far. Quadratic polynomial using the quadratic formula. Now remember to document what it does. So it places the results in those two pass by reference variables. That pretty much is clear because it's root 1 and root 2. We don't need to document that because the variable names themselves state that that's self-documenting code. But what I do need to document is the return value. Returns a non-zero error code for any input errors, right? 0 otherwise. Right? Now you can go on and document that even further if you want and say, well, it returns a 1 if this type of error occurs. It returns a 2 if this type of error occurs. Or you can go ahead and use an enumerated type. I'm not going to go all the full 9 yards there, though. What I'm going to do is I'm going to start implementing this. Over here in the source file, I'll jump to the bottom, repeat the signature, and now we can start writing this. What is the very first thing I should do always if I'm doing error handling? Do I look before I leap, or do I leap before I look? Which one? Which one's safe? I'll take you to the edge of the cliff, and then I'll ask you which one, right? So look before you leap, right? So if I need to determine if there are error conditions here. What were some of the errors when we originally did this a few weeks ago that we encountered? So you remember your, what is your quadratic formula here? So let's just go ahead and write it. It's negative b plus minus square root of b squared. I'll just go ahead and go with b times b minus 4ac, right? All over 2a. 2 times a. There we go. Right? And put that in the numerator there. There we go. We're going to have to still edit that. But just to remind you, that's what the quadratic formula looks like. What could lead to trouble with this computation here? If a is equal to 0, what would we end up doing? Dividing by 0. So I'm not going to do that. If a is 0, then I will immediately return with an error code that's non-zero. I'll just go ahead and do one right now. Again, if you wanted to go the full 9 and define an enumerated type and put all these errors in there, fine. Go ahead. Right? Else, if, is there any other types of errors? What could happen here? If that's a negative number, can we handle complex values? Not with regular old C. So if that is less than 0, 0 is fine. The square root of 0 is 0. Right? If that's less than 0, then I'll return a different error code, 2. Okay? Are there any other types of errors? Be careful now that you're doing pointers. What is a bad pointer? What did Bret Hart observe? Null. So if that root 1 is, else if that root 1 is null, what else could be null? Root 2 is null. In fact, I mean, it's not going to make any difference in this particular case, but generally what you need to do is you need to promote that to the top. Null pointers should be the first things that you check. All right? If either of those is true, then I'll go ahead and return another one, 3. Right? Okay. If we've gotten to this point in the program, in this function, then that means that everything is pretty good, unless you can define, think about another error condition here. Right? I don't think there is. But now we can go ahead and make this computation right here. So let's go ahead and set root 1 equal to this thing, where it's the positive root, and then root 2 will be equal to the negative part. Right? Now careful. What is that thing? Let's just look at this line right here. What is that thing on the left-hand side? Is it a regular old variable? Nope. It is a pointer. So the left-hand side is a pointer. What about the right-hand side? That's a regular old variable value, right? Does that match up? Nope. So what do we need to do to the left-hand side to make it into a regular old variable? The dereferencing operator is the star, right? And again, it's just that which one was it? Put it on a post-it note until you got it in your head, right? Regular old variable to a pointer variable would be the ampersand, right? That gives you the memory address. If you've got a pointer, right? I'm pointing now. Then I dereference it using the star operator to make it into a regular old variable, so I can set its value like this, right? Needless vertical space. Let's go ahead and put that there. Right? Is that it? All right, let's go ahead and try to compile it. GCC-C to compile without you can compile your library without creating a executable file. What should you always do though? What's being hidden here? There's an error that's being hidden because I didn't use the wall flag. Let's use that wall flag. It's warning me that I've reached the end of a non-void function, a function that returns an integer. I returned it here, here, and here, but did I end up returning it down here as the catch-all? Nope. So return 0, no error. Okay. Coming back over here, making sure that I always use the wall flag and address all of those warnings. Right now we're all good. I'm going to come over to my testing file. Remember the way that we set this up, and you do have to hand something like this in. You can have a tolerance. You have a number of tests passed, number of tests failed, etc. We were testing here the round descents. We tested round descents, round descents. Now let's go ahead and test our new function here, the compute. What did I call it? Compute roots. Yeah, compute roots. All right. And I'm just going to put it over here as a reminder. I'm going to get rid of that cruft after I'm done. And so I need a double A is equal to 2.0, say. Double B is equal to 3.0. Double C is equal to, let's change these around because I want an actual real root. So 4 and 1.0. There we go. All right, and I do need values in order to return, again, quotation marks there, return the values of the roots here. Double R1, root 1, and root 2. Right? And if you want to, you can capture that error code. I think I was using, I don't have an error code, so I need an error code. Int error code. There we go. Error code is equal to compute roots. And I won't pass these out. A, B, C, and then what about root 1 and root 2? These things are pointers or regular old variables. Root 1 is a regular old variable, right? But it's expecting what? A pointer. How do I take a regular old variable and make it into a pointer? Ampersand. And ampersand. There we go. Now, what's your expectation out of this? Again, the pattern here is that we've got our actual output, which is actual root 1 and actual root 2, if we want to rename them like that. All right? Actual root 1 and actual root 2. What should the expected root 1 and expected root 2 be? So, what should they be? We'll go ahead and run the program and find out, and then put them back in there. Is that a proper test case? No. Proper test case would mean you pull out your calculator and you start doing stuff, or you let Wolfram Alpha do it for you. So that was 3, 4, 1. So 3x squared plus 4x plus 1 equals 0 roots of. Right. There we go. Negative 1 and negative 1/3. Okay. So the expected root 1 should be negative 1, and this one should be negative 1/3. That takes you back to like the week 2. Is that correct on line 58? This thing right here? What happens when you divide an integer by an integer? Truncation. What will this end up being? 0. We don't like that. We can do it like this if you want to. Like that. Or just write what it is. 3, 3, 3, 3, 3, 3, 3, 3, 3, 3. Right? That's fine too. All right. So now I need to check, and I'm going to grab this this code right here so I don't have to type so much. And copy pasta. Yes, bad. But remember that the expected root 1 here and the expected root 1, actual root 1, the difference there, they could be off a little bit. It's probably okay if it's negative 1.00000001. So if the difference between those two things is small, then we'll pass it. However, we also need... Yeah, go ahead.
Sorry, in GCC, why did you use the -c flag?
The -C flag compiles it. In the financial utils, there's no main here, right? This is just a collection of functions. So you have to compile it, but not link it to create an a.out file. When you do this, it creates this .o file over here, this financial utils.o file. That's not something that you can run. If I tried to run that, in fact, it's not even picking it up. NCL utils.o, right? It's not a runnable file. It's just a bunch of machine code. Anything that is runnable has to have a main. And that's why over here in this test, we're putting all the tests into main.
Right? So it's just an intermediary step.
Yeah, exactly. And I mean, that's what, if you don't specify that, let me go ahead and get rid of it. It's going to assume that there's some main in there that it's going to find and does all of those steps for you. And then it'll fail out because it has no idea that there's no main. Undefined reference to main. I can't build an a.out file for you. Right? So the -C just compiles. It does not produce an a.out file. Right? All right. Okay. Back to this. We have 2 roots that we need to test here. So we could go ahead and put it into an AND right here. Fabs, and then expected root 1. All of this stuff should be like that, but it should be 2. Right? So only if root 1 and root 2 are within the tolerance do they pass, and then we fail it otherwise. Right? And once again, we got this from a third party. Me pulling out my calculator, using some sort of calculator online, something else entirely, other than our code. Right? So now I've got my financial utils. I need to GCC financial utils tests, which has my main, and then I need to bring in the my library, so financial utils.o. And I need to bring in the math library because I'm doing math stuff now. And then also make sure to turn on the wall flag so that you get warned of anything that that could be a problem. Right? In fact, there is a problem. Warning: error code is set but not used. That's one of those warnings that you can kind of ignore. You could check for it, right? That's a valid input, right? So we could check that the error code and the error code is equal to 0. There we go. Or not equals, but equal to 0. Equals. There we go. All right. And now that warning goes away. I'm checking because it's basically producing 3 outputs: the error code and then the 2 roots. I want to check that all 3 of them are as expected. Okay. So, oops, let's get rid of that. All right, so GCC, and let's go ahead and run this now. And I don't know how many tests I had before. Ooh, but now one of them is failing. Right? Why is it failing? Could it be my code? Or it could be my tests. Right? Or it could be both, and I have a bug in both of them. Unfortunately, it just says failed, right? That's not very satisfying. How does it fail? Well, I wrote the code that says it fails. I might want to be a little bit more verbose about this. Instead of just saying passed or failed, let's say why it failed. All right? So, failed. %f is versus %f. Let's go ahead and print out, say, the expected root 1 and the actual root 1. Right? And there. I think that'll tell us why it failed. Right? It failed. Right? Apparently, the roots were swapped. Right? Why? Because this one was in the code here. We were doing the positive root first and then the negative root second. All right, that's fine. I can come back up here and I can swap these 2. Right? I'll put this one over here and I'll put this one over here. There. Right? It's the same answer. It's just that it's a different order. Right? There, now it's all passing. Right? But the point is that you may want to make your own testing a little bit more verbose. Say it passed. Here's the actual output. Here's the correct output. Hey, they match, right? Or maybe you don't want to be verbose on passes, but certainly you should be more verbose. That is printing out more information on failed, right? You could print out more, right? Do the expected root 2 and expected root 2, right? And I'll go ahead and tab over here to make it look nice. Or maybe it failed based on the error code here, %d, and that would be the error code, right? And we expected 0, right? or I guess the expected would be 0, and then the error code would be like that. All right, so that if we in fact do fail on this, I'll make this fail by giving it a bad test here. Yeah, go away. All right, there we go. All right, now you're getting a whole bunch of information, right? That the roots are not, okay, no, that one matches, but that one doesn't. Okay, there's a problem with that. I can zero in on that one value being wrong. All right. So writing these tests with a little bit more information, especially on a failure, is going to be a lot more beneficial to you. All right, so let's have some fun with another function here. And again, this is the recommended reading. This is from my book. It's free. It's online. It's 651 pages if you want. But it also covers Java and PHP. But anyway, it's got some extra exercises. If you ever, if you're ever needing more practice, wanting more practice, you can go ahead and reference this book for other activities. Some of them I've already put into your hack, for example. There's one from a hack. There's another one from your hack this week or next week. I forget which one it is. But let's go ahead and do this one. Write a function that scales an input, x, to its scientific notation. So for example, if I gave you 341.15, it should be scaled down to 3.1415. Right? Not only that, but it's the value that it's scaled by is -2. I want you to return both of those things. If your language supports pass by reference, then make sure to change the value x, right? It has a new value, but then also return -2, or return the amount that it was scaled by. And it's by -2 because if you go 10 to the -2, it's been divided by 100, right? 10 squared, but negative, right, is going to be divided by 100. Okay. All right. So first thing is first, the prototype. I'm going to go ahead and return any error codes, maybe. Right? I'm going to call it scale. Right? And I'm going to take a variable int, or not int, but double x, right? By reference, because remember x, do we want to change it or do we want a new one? Right? We could divide. This goes to design, right? That we could end up returning x, like a double value that gets scaled, but then also we need to communicate n, the amount that it was scaled by, right? We could do this as, we could return that value, fill in this value, or what I'm going to do is I'm going to do the same pattern that we've been doing over and over here. I'm going to go ahead and take in x and n by reference, because I'm going to change x and then fill in n. If there are any problems with the input, I will return an error code. Right? So scales the given value x, stored in x, up or down. Right? The example here is it's scaling down. We're going from 314 down to 3. What if it's less than 1? Then we need to scale it up. If it's 0.01, right, we need to scale that up to 1, and n will be 2 in that case. Right? All right. So scales up or down, and communicates how much the scaling up or down to scientific notation, and communicates how much scaling was done by setting the value of n. And in fact, what you can do is you can take that example, right, for example, and put it into the documentation. If x is equal to 314.15, x would scale to 3.1415, and n would be equal to -2. Right. You can put examples into... Okay. Yeah. How do I get rid of that? There we go. All right. Whatever the hell that was. Right. So you can put examples into your documentations. Okay. All right. Again, it's no longer financial utils, but I'll go ahead and cut and paste the signature, and let's go ahead and implement this now. Is that big enough for back there? Yeah, it's big enough online. It's I think I'm broadcasting in 8K, so You should be able to zoom in even if it's small type, right, on the live stream. Right? All right, anything that could go wrong here? Null pointers. If x is null, or if n is null, there's nothing you can do. Return with an error code of 1. Remember, I always like to just immediately jump down to the end, and don't forget to return an error code of 0. All right. Now let's just think about that one example. All right, it's going to be larger than 10, right? So we need to scale it down. Do you know how many times you're going to scale it? 314.1415, something like that. We want to make it into 3.1415. Right? Do you know up front, though, that you're going to be dividing by 1 to 10 twice? Nope. So what kind of a control structure here would you want to write here when you don't know how many times you're going to do something over and over again? A while loop? All right. So while x is greater than or equal to 10, right? What happens when it's equal to 10? We end up dividing by 10 and we get 1, which is exactly where we want, right? So if it's 10, we still want to divide it by 1. Right? Then I will say x is equal to x divided by 10. Right? So problems with this. What is x again? Is x a value like 314.15? No, what is it? It's a pointer. Right? So how do I take that pointer and make it into a regular old variable so that I can divide it, compare it, and then divide it by 10? Star. Right? Likewise, when I divide it by 10, I need to do this and this. Right? Is there a shorthand way that I could have done this? Divides equals 10. There we go. I hope that's. I'm pretty sure that the that this will work because, but there is a kind of a order of operations here because this is an operation and then this is also an operation. Hopefully this one occurs before this one, but I'm pretty sure that it does. Right? Okay. Well, that works if it's greater than 10. But what if we had something like, say, 0.0045? What should that end up being in scientific notation? 4.5 times 10 to the negative what? 3? 1, 2, 3. Right? And this is times 10 squared. Right? Okay. So is this while loop going to work for the second example? Nope. Yeah, so this will work if x is greater than 10. What happens if it's less than 1? If x is less than 1, what would we end up needing to do? While x is greater than or less than 1.0? I guess less than or equal to, no, strictly less than, right? Because once it hits 1, right, then we're good, right? That's in scientific notation. So x is equal to x times 10. We're going to scale it up, okay? Again, a shorthand way of doing that would be times equals 10, right? So should I put this into an if-else if? Else if. I could, but guess what happens with the while loops? They end up taking care of that for me. Look at it just as it is right now, right? If x is not greater than 10, will this while loop execute? Nope. So this won't execute. This one will end up executing. Now, think about the opposite condition. If x is less than 1, then, or I guess, if x is greater than 1, I screwed up my thought process there. But if it's greater than 10, then this will execute and this one won't execute. If it is less than 1, then this one won't execute, but then this one will. Right? So just leaving them like this is probably going to be enough without all that cruft code. Simpler code is generally better code. Right? All right. And, uh-oh, what else was I not keeping track of? This thing right here. Right? So what I could have done is I could have said n is, am I going up or down here? Up, okay. We'll see if that's correct later on. What am I doing here? Going down. Right. Headache here. I don't know what the order of operations is here. I'm pretty sure what the order of operations is here, but I'm not sure about this right here. Is the plus plus done first, which would be wrong, or is the dereferencing operator done first, which would be right? I have no idea. Not only that, but I'm going up or down. Where am I starting? What if neither one of these executes? How did you scale it? Say 3.1415 should end up being what? 3.1415. And n should end up being 1? Or, well, it's going to be 10 to the n, so that means that I multiplied by 10, right? So it should end up being 10 to the 0 because you didn't do anything, right? This is going to end up being 3.1415 times 10 to the 0. 10 to the 0 is 1, so it just ends up being itself again. Right? So where should I have started? At 0. Right? Can I make the assumption that somebody gives me an n that starts at 0? If I do, then that's a wrong assumption. What if I break your code by giving it 5? And then you, without this line right here that sets it equal to 0, now you're going up. Now it's 6, 7, 8, right? And it's completely wrong. So if you have an assumption on what's stored in this n, then it either needs to go in the documentation and it needs to be a correct assumption or a reasonable assumption, or you need to take care of it yourself. Now, is that how I set it equal to 0? It's a pointer, so dereference it. Right? Okay. And then return 0 down here. Let's just go ahead and test this and see if it works. Let me go ahead and make sure that everything compiles first. GCC, come on. There we go. All right. Value is not, computer is not set. Yeah, I think it's warning me about this. That this is, first of all, it's not great practice to do this because I don't remember which one of these is occurring first, but it's probably warning me. Value computed is not used, right? So that's telling me that it's not doing what I want it to do. So let's come back up here and rethink this. Generally, what I like to do is if I'm going to set a pointer value, I only want to do it once. I don't want to keep doing it over and over and over again. So let's go ahead and create our own variable called power that starts at 0. This power will go up, or this power will go down. Right? Or exponent if you wanted to call it that, or whatever. Then what I'll do is at the end, I will only set n to that power. Oops, power. Once. Now, there's no mistake here at all. This is a regular old variable, right? Plus, plus, minus, minus. There's no guesswork here at all. I believe that the warning probably goes away now, right? Because now it's this is just a regular old variable. There's no getting it wrong, right? But there is getting it wrong when it's a pointer variable like this. Arguably, you could go ahead and make another x, but I'm not going to do that. Right? All right, let's come back over here to my tests and see if we can contrive a test for this one. Did I already declare x? I don't think I did. X is equal to 31415. 1415. Okay. And then int n. Right. There we go. And I will go ahead and say error code. Error code is equal to, what did I call it? Scale. There we go. All right. Scale. And I'll pass in x by reference, n by reference. Those are regular variables, so to turn them into pointer variables, ampersand is needed. Right? Now, what's my expectation here? Right? If, and then here you can go, these are floating point numbers still, so you'll probably want to follow the same pattern here. Right? If the absolute difference between x and say 3.1415. I can put that into a variable if you want. I'm just going to go ahead and leave it as it is less than or equal to, what was it? Tolerance? Right. Then it passes. And I don't want to type, so I'm going to go ahead and grab all of this stuff. There we go. Come on. There. All right. It passes. Right. But also I need to check n. And n, I forget what the expectation here is. It should be like 2, right? And if n is equal to 2, then it passes. Otherwise, it failed because the x here is not equal to 3.1415. And that's probably why I should put it into a variable name, double x expected is equal to that, and use that instead of this variable, or this number that I have to repeat and copy paste everywhere. Also, when I go to make another test case, I don't have to change those. I can just change them in one spot. X, there we go. And then I don't care about the error code, but I do care about n. And what's the expected n? Int n expected. And this should be 2. It depends on how you look at it. Are you measuring how much you scaled or how much it should be in the scientific notation, right? I think this might be different than what I had in the book over here, but that's fine. All right, so bring all this stuff together now, right? And run it, and yay, all 5 of them still passed. Right? Because I went into the work of putting all of this together, I can go ahead and do it again. Right? But I don't need to I can't redeclare these things. So I'll just go ahead and change it to n expected should now be, and what was my other example over there that I wrote down? This one. Now I get rid of the cruft, right? We're still seeing a lot of folks leaving crufty stuff, debug stuff, dead code stuff, overly verbose comments, like overly too many comments, line by line. And we shouldn't have that anymore. But this one, 0.05, that's my x. Right? And I should end up with 4.5. And then this should end up being -3. -3. Right? And I don't have to change anything else, I guess. I should have changed this to expected n up there instead of 2. There we go. And I don't have to change anything else because I reused all the same variables. So GCC it, run it again. Hey, it still works. Right? My output is matching my expectations. Let's write one more. Okay. In fact, I'm going to make it very, very similar to this one. I'm going to make it negative. Right? Now, what should be your expectation here? -4.5, and you would have still scaled it by the same amount. Right. Is this going to work or not? Cross my fingers here. In fact, why did I think, oh, we should test negative values here? Remember code coverage? You want to test all possibilities, or as many possibilities as you can. What happens when it's positive? We have good assurance that this code is correct. But what are the other possibilities? What happens when it's negative? What's going on there? The test suite's not even terminating. What's going on? An infinite loop. Right? So, even though the test didn't say fail, the testing itself found a bug that there's going to be an infinite loop. So, I'll put a note in here to do fix this infinite loop. Right? And until then, I will go ahead and comment this stuff out. Copy it. There we go. All right, we'll fix that maybe if we have time here. But what else should I be testing? I tested positives, I tested negatives, and I know there's something wrong. 0? Good. What's your expectation here? It should not change. Right? What's your expected, what happens here at all? Is there a scientific notation version of 0? It's just 0 times 10 to the 0, right? That would be the standard one, right? Does that pass or not? GCC. And run it. Same issue there. Right? So to do. Fix this infinite loop too. Right? I've got myself two to-dos here. We're not going to. We won't do it here, but actually, I think we could do it here pretty quickly. What's going to happen when it's negative? Well, let's just do 0 for now. So it's x is 0. Does this while loop execute? Nope. Is x less than 1 because it's 0? Yep. So this one will execute. What do we end up doing? 0 times 10, which is 0. Power minus minus. Did we make any changes to x? Nope. So infinite loop right here, just by walking through it and finding out. What's a solution that we could do here? So sometimes those corner cases, those edge cases, have to be dealt with differently. Right? Let's just go ahead and take care of it because it's one thing. If x is equal to 0, then we'll set x. I don't have to set x because it's already 0, but I should set n to be 0 and then return 0. Right? That ensures that my while loops down below don't get executed. So let's compute all, again, I have to compile from scratch here because I made changes to my library. Right? Then I can compile my tester. Then I can run my tester. Right? And now they are, all 7 of those are passing. Right? Once again, this can get kind of unwieldy if you're always repeating the same stuff over and over. And if you're not a touch typist, well, first of all, become a touch typist. But if you're, even then, you're typing this over and over and over again, I don't want to do it. In fact, I'm not doing it. Do you see what I'm doing? I'm going back in my history here to where I typed it once, right? Just hitting the up and down arrow keys will take you through your history. And then do that, and then do that one. If you want to go the full 9, though, you can actually write your own make files. We're not requiring you to. You won't hand them in. But if you want to take a look at our make files and see how they're done, you can use those as a model so you don't have to do this over and over and over again, right? And so you could just type make and be done with it. But, of course, there's no make file here. Huh? Stop. Oh, yeah. It just stopped, it says. Stop asking me to make something. I don't know how to make it. All right. All right. One last, so we won't do it. In fact, I'll leave it as an exercise here. What would we do with that negative value? I don't want to write more code. All right. Else if x is less than 0, then what could we do? I know that this code works, right? I could change x to be times equals -1, right? Multiply by -1 and you get x, positive x, right? You could do fabs too if you wanted to, whatever, right? But be careful. Once this stuff works, right? If it was originally negative, you still want it to be negative, right? If it was originally negative, then make sure that you're fixing it. X times equals -1. Now, how do you do that? I want to know if it was originally negative. Ideas? Let's make a variable, a Boolean variable, right? Is negative, right? And initially I'll say that it's false, right? Is it false or false? I think it's false, right? False. All right, all uppercase or lowercase. And then what I can do is I can set, oh no, it was negative, so is negative is equal to true. Is negative, if it was originally negative, then make sure that you correct yourself down here. This is a common pattern all over the place. I've got code that works for one situation. I can take another situation and transform it into that situation and then just reuse that code as long as I make the appropriate corrections after that. We did that with round descents, if you remember. I don't know how to round to the nearest 100th, right? But if I multiply by 100 and then round, and then divide by 100, it does the work for me. Right? I don't want to write more code. Right? I don't know if, hopefully this worked. That was a very quick way of doing it. Quick and dirty. No, it's not dirty. All right. Fine. Include, if I'm going to use standard Boolean stuff, what do I need? stdbool.h. Right. There, and do I need it over here too? Oh, it's already there. Good. All right. There we go. There we go. And let's see if that fixed all of my test cases. Yes. 8 test cases. You don't have to do a lot of work on test cases, right? Once you've got 1, 2, 3, right? It's pretty easy to churn them out, especially if you've got, for your hack this week, just use Wolfram Alpha. I think they're all mathematical functions anyway, right? Next week when you start doing, or when you did your lab, right? Look for an online RGB to CMYK converter, right? Maybe Wolfram Alpha does something like that. Maybe ChatGPT does something like that. You can use ChatGPT to convert stuff. I've used it before, and it's been terrible because it doesn't get things right all the time. So I would caution you against that. But you could... no, that's not what I want. Probably this one, where you've got an RGB value. What? It wants to do full files or something. Maybe I should have said designer. There we go. There's something. So if you wanted to convert pure red 255.00 to CMYK, there it is. Right? Just use some online calculators or something. If Wolfram Alpha doesn't support it, it's not mathematical or something, you can go ahead and use something else. Right? All right. Then I'll see you on Monday, and we will start on arrays next.